All right, let's talk about a programming language that is, and I mean this literally, everywhere. It's running the massive servers that power our global economy, and it's right there in your pocket on your Android phone. We're talking about Java, of course. It's one of the most influential pieces of tech ever. But why? What's its secret sauce? Well, let's crack that code.
I mean, have you ever stopped to think about how the same app can work on your phone, then your laptop, and even your smart TV? They're all completely different machines, right? Different companies, different guts inside. Back in the day, for a software developer, this was a total nightmare. You'd have to write your code, and then rewrite it, and then rewrite it again for every single type of computer out there. It was a huge mess. And that's the exact problem Java was designed to fix.
And it all started with this simple but honestly revolutionary promise. Write once, run anywhere. That was the whole idea. That was the mantra. The concept that a developer could just sit down, write their program one single time, and then it would just work flawlessly. On a Windows PC, a Mac, a Linux server, you name it. This was an absolute game changer.
Okay, so how did they actually pull off this magic trick? I mean, how is that even possible? Well, the secret lies in this really clever two-step process that involves something called bytecode and the Java Virtual Machine. You'll hear it called the JVM.
Seriously, think about it. How can one piece of code work on so many different machines? Your laptop's processor and your phone's processor, they speak totally different languages. The solution wasn't to teach the code how to speak every single one of those languages. No, that's way too complicated. The brilliant idea was to create a kind of universal translator for every machine instead.
So here's how it works, and it's actually pretty straightforward when you break it down. First, the programmer writes their Java code like usual. But then, and this is the key part, they don't compile it for a Windows machine or a Mac. Instead, they compile it into this universal intermediate language called bytecode. This single bytecode file is what gets sent out to everyone. And then finally, your device, whatever it is, has its own Java Virtual Machine, the JVM. And that JVM is the translator on the ground, taking that universal bytecode and turning it into the specific instructions that your exact machine needs to run.
So, what exactly is this bytecode? Well, this is the real secret sauce. It's not code for Windows. It's not code for Mac OS. It's machine code that's built for one thing and one thing only, a virtual machine. Think of it like a universal language that any computer with a JVM installed has been taught how to understand.
Yeah, the JVM is basically like having a UN universal translator living inside your computer. You hand it that one bytecode file, and the JVM on your Windows machine knows exactly how to translate it for Windows. Then you take that exact same file, give it to a Mac, and its JVM translates it perfectly for Mac OS. That right there, that's the write once, run anywhere promise made real.
And hey, just a quick side note, because you'll probably hear these terms thrown around. The JVM is that core virtual machine we've been talking about, the translator. Now, if you just want to run a Java app, you need something called the JRE, the Java Runtime Environment. That's the JVM plus all the basic library code it needs. But if you're a developer and you want to actually write the code, you'll need the JDK, the Java Development Kit. That's the whole shebang, the JRE plus the compiler and all the other tools you need to build stuff. But, being able to run anywhere was only half the reason Java got so huge. The other massive piece of the puzzle was its whole philosophy on how to organize code. It's called Object-Oriented Programming, or OOP for short, and it's a really powerful and, honestly, more intuitive way to build software.
So the core idea behind OOP is to model your code after things in the real world, using classes and objects. Think of it this way. A class is just a blueprint. Let's say the blueprint for a car. It says every car will have 4 wheels, an engine, a color, etc. But the blueprint itself isn't a car, right? An object is the actual car you build from that blueprint. The red sports car in the driveway is one object, the blue minivan is another. They're real, individual things created from that one single template.
And every single object, doesn't matter if it's a car or a bank account in your code, has 2 key parts. First, it has its state. That's just what the object knows about itself. It's data. For our car, that's its color, its current speed, how much gas is in the tank. Then it has its behavior. That's what the object can do, its actions. Things like start engine, accelerate, turn left. What's so cool about this is that it bundles the data and the actions that use that data together in one tidy package.
Okay, I know that might still sound a little abstract, so let's make it super concrete with a really simple example. We're going to look at a class designed to keep score in a cricket game. So here's our blueprint, the Cricket Scorer class. Super simple. Its state, the data it needs to hold on to, is just one thing,
the current score. And its behaviors, the things it can do, are actions like adding 4 runs, adding 6 runs, or just telling us what the current score is. See how it's all bundled together?
And now, let's see an object made from this blueprint in action. So, step 1, we create a new Cricut Scorer object. Its internal state, the score, automatically starts at 0. Then in step 2, we tell it to perform one of its behaviors. We call the 6 method. Boom! The object's internal state changes, and the score is now 6. Then step 3, we call another behavior, 4, and its state updates again to 10. This is the whole point. You have these neat, self-contained objects that manage their own data. And when you're building massive applications, this kind of organization is an absolute lifesaver.
So you see, when you take that revolutionary run-anywhere technology and you combine it with this incredibly powerful way of organizing code into objects, well, you get a language that was just built to last. From giant web servers all the way to the Android apps on your phone.
Look, Java's dominance was never an accident. It really comes down to this killer combination of features. First, that platform independence. It solved a huge, expensive problem for developers. Run Anywhere was a game changer. Second, the object-oriented design gave them a sane way to build and manage huge, complicated applications. And finally, over the decades, this massive ecosystem of pre-built code and tools has grown around it. That means developers almost never have to start from scratch. These 3 pillars? That's why Java is still powering so much of our digital world today.
You know, Java's write once, run anywhere was the perfect solution for the problems of its time, a world with a bunch of different desktops and servers. But today's world is different. We're dealing with massive distributed systems, artificial intelligence, and billions of tiny connected devices. So it kind of leaves you with this big, fascinating question to chew on. What's the next huge, run-anywhere style problem that programming needs to solve? Something to think about. Thanks so much for joining me for this breakdown.